All right, so very pleased to be here with all of you. I think this is an exciting session because we get to actually look at some of the benefits and things which Gen AI can do. I mean, I'm sure, anyone been to a Gen AI talk this conference? Yeah, okay. Way too many Gen AI talks at the conference, but also see where some of the shortfalls are, because if you're building RAG applications, you're actually doing stuff with Gen AI, I'm sure you're struggling with getting to get like high accuracy results, which actually like meet the needs of enterprise requirements. Great for things which are consumer facing or where you have a human in the middle. But if you really want to trust a large language model to answer by itself, that's quite challenging. And just to make this a little bit more fun, we're going to use a Twilight Zone theme. It feels like we're back in kind of this Twilight Zone era where LLMs are taking over the world and we're doing all this advanced stuff, are invading our lives. And I think if you went back maybe 10 years and you said, well, how are computers, how is AI going to enter our life? You might have imagined something closer to this, right? Like giant robots walking into our lives and physically doing things, helping the elderly, exploring the moon. But actually what happens was they invaded our life with language, with creativity. And I think that this is something which, if you look at Gen AI technology, what it's good at, what things it really excels at, it can build and it create a lot of content, of course, based upon a large pool of knowledge, which it learns from us humans and which it kind of builds upon. But it's coming in an entirely different way in a whole bunch of different use cases where it can do things which are either repetitive tasks for humans, or areas which require large knowledge bases, are things where you really have to go through info. We did a great panel yesterday with Lior, Linda, myself, and talked through a bunch of the different use cases for security, but also related to Gen AI and how that's getting into the enterprise. And one of the big things is that it can be used to detect malware. It can be used by hackers as an exploit where they can take advantage of Gen AI algorithms as a way of figuring out potential attack vectors. And even the LLMs themselves open up potential security holes, because if you now execute things which are coming out of an LLM, it's possible to send in inputs in a way which would cause it to actually execute malicious code on the payload. So a lot of interesting things which are happening in the LLM space, and it really feels like the age of Gen AI is upon us, kind of. So all the graphics I'm using I guess they're up there for you guys. All the graphics I'm using in this presentation are scenes from the Twilight Zone, which were recreated by an artist, kind of like modern photography. This is a scene where the elderly couple's getting their new bodies. Hopefully this works for us too, so we can outlive the robots. Otherwise, Gen AI is going to long outlive us in terms of longevity. Now, before explaining where we can help Gen AI, let's talk about cases where Gen AI falls apart. And I think one of the things which we're all aware about is there's certain cases where LLMs will hallucinate, basically make up information and create things which are not real. And it's actually quite tricky because they're constantly tuning the algorithm. They're fixing cases where the LLMs respond incorrectly. Well, say things which are politically incorrect, which are discriminatory. But if we kind of coalesce the things which Gen AI is not good at, so typically not very good at math. I mean, simple math problems, of course, yes. But when you get into complicated math problems, Gen AI falls apart. Actually, anything particularly tedious. If you ask it to do a simple ROT13 cipher, it'll do it perfectly for the first 5 or 10 characters, and then it'll get 1 or 2 wrong as it goes on. Biases also are quite bad. So the training material has a lot of biases. Those have to be manually corrected so that it doesn't, spit things out which would be politically incorrect. And also reasoning, the models don't reason the same way we do as humans. We'll talk about how they reason in a bit, but it's another area where they're weak. So what if we kind of get, the Venn intersection of these three and try to trick ChatGPT? So I did these a couple months ago on ChatGPT 3.5. They keep coming out with new algorithms, so if you test these today, you'll probably get different results. But you can always find these little corner cases by kind of testing the model at the limits of math and reasoning or other combinations of these. So let's see how well you do versus the large language model. 5 developers walk in a bar 5 times. Developers leave the bar in groups of 3 times. What's the square root of the developers left in the bar? Anyone want to just shout out an answer if you know it? Just shout it out. Okay, so we got 4. Does that sound pretty reasonable? Yeah? Okay, so this, I think for us, this is an easy problem because it's basically a 3, 4, 5 triangle, right? Like you square and subtract and take the square root. Or you can do the Pythagorean theorem. And this is simple math, so we'd expect ChatGPT to also get this right. So this is what I put in the response back, and I spread out in a few slides to make it easier to read. Okay, so break down the scenario. Initially, there's 5 developers in the bar. Each developer walks to the bar 5 times. The total number of developers in the bar is 5 times 5, 25. So good so far. The first time developers leave the bar in groups of 3, 5 minus 3 is 2. Okay, so we already, like you can see, there's a reasoning here about people leaving and exiting a bar, and also math involved, and it's doing the math correctly, or what it believes the math is, but it got the math wrong. It should be 5 squared minus 3 squared. The second time developers leave the bar in groups of 3, it should be 2 minus 3, -1 developers in the bar. Now it understands there can't be a negative number of people, so it corrects that to 0. And then it does that again and corrects it to 0 again, gets the square root, 0 developers left in the bar. Okay, so good try. It failed. Humans win for once. And I think that this shows one example of the limits of kind of like math and reasoning, but something which probably matters to us more is can we pull bias out of ChatGPT? Can we get it to say something that's kind of offensive? And I think that one of the things we know is there's a big gap, especially in the tech industry, with women getting involved in technology education. Actually, we have some hope for the future because my daughter, who's in the audience, is getting a computer science degree. So I think some folks actually, like the computer science field's opening up and it's becoming more equitable, but at least at our current folks in the workforce, we're a little bit biased. And let's see if ChatGPT mirrors this bias. So there's a class of computer science students composed of 10 boys and 5 girls. 5 students drop out of the class. How many boys are left taking computer science? Who wants to take a guess at this? 10? It has to be 10, right? Okay, so I mean, this is a bit of a setup because the answer is not known, but ChatGPT will never give you, say it's an unknown answer. It will always make up an answer. It will convince you that's exactly correct because it's very eloquent, it writes very good English. And of course, ChatGPT had an answer for us. Initially, there are 10 boys, 5 girls in the class, so 10 plus 5 is 15 students, so it got that right. If 5 students drop out, then we're back to 10, so it also got that right. Now, this is where it gets a little weird. It says, since we know there were originally 10 boys in the class and none of the girls dropped out, so it's corrected the bias. A girl will never drop out of computer science, according to ChatGPT. All 10 students left in the class are boys. Therefore, there are 10 boys left taking computer science. Okay, now what happened here? So it fixed the bias and said girls will never drop out, but the math still had the bias built into it because it was based off the previous bias. So this shows you that there's little ways you can trick the model based on how they've set up the algorithms to kind of take biases out of it. And we'll try it one more time with a different set and see if we can trick it a second time. So this is reasoning and bias rather than math. And my sister's a nurse who has 3 kids. 2 are boys, 1's a girl. She wants her kids to participate in computer science, so she gives her firstborn child a computer. Is it more likely her first or second son does computer science? Okay, now this is a bit of a leading question, right? So we don't know if her first child was a boy or a girl. And therefore, we can't actually answer the question definitively, but there's 2 boys and 1 girl, so it could be either the boy or the girl who does computer science. And we asked which son, so it could be neither of the sons. It could be son A, son B, or neither of the sons. Okay, so ChatGPT's response. Given your sister gave birth to her firstborn child, who is a son, so it made something up, like that wasn't in the initial question, right? A computer in hopes of fostering an interest in computer science, it's reasonable to assume that her first son is more likely to pursue computer science compared to her second son. And then it goes on to explain why giving your child a computer doesn't guarantee that they'll pursue a degree in computer science. So, also got this one wrong. It said the boy. So we've shown 2 failed biases, 1 failed kind of logic around folks. And the question is, why is the LLM behaving like this? Why do we get answers which are very authoritative, which actually are sometimes helpful, but occasionally very misleading? And what LLMs are really, really good at is kind of like it mirrors the human brain, where the right half of your brain, which is imaginative, holistic thinking, intuitive, arts, rhythmic, nonverbal cues, etc., that is all things which LLMs are good at. The left side of here, so logic, sequencing, linear thinking, mathematics, they're good at facts, but only the facts you've trained them on. So if you're doing any sort of enterprise LLM, you really need to feed it the information which it requires to answer the question. And thinking in words, these are all areas where it doesn't do a good job at. And I think to help explain why LLMs behave like this, it's important to understand how they think and then also how they do reasoning, because it's very different than how we think as humans and how we do reasoning and logic. So first of all, they don't think in words, they think in word vectors. Word vectors are basically concepts pulled out of the pieces pulled out of the sentence and related to each other by statistical probabilities in vector space. And it's a multi-tiered vector, so it's encoding a lot of different information when it goes through different transformer stages. A good way to get an idea about how word vectors work is there's a great site at vectors.nlpl.eu, and it lets you explore and type in 2 different words and then see the relationship of that to different words and see how word vectors are composed inside of a LLM's embeddings. Now, I think this is a good way of looking at how the transformer stages work and encode the information inside of the word vectors. So as a hypothetical sentence, if you gave it a developer's best friends to write code as AI, each transformer stage will try to pick apart and create relationships between the word vectors based upon some understanding of the sentence or some understanding of the parts of speech. So in the first part here, it's picking out, like subjects. So a developer and an AI, those are both subjects or actors in the sentence. Writing is an action, so it encodes a little bit of information in the word vector for similarities. The second stage here is relating those to the other parts of the sentence. So the friend is friend to an AI. The code is written by the developer and the AI together. So kind of relating those ideas together and concepts. And then each transformer stage you go through adds more and more complexity. And then modern models use hundreds of transformer stages to encode a lot of information in the word vectors, and then take it through a feed-forward layer in a neural network where you're basically getting the next most likely word vector out of your model and then reapplying that to try to build out an answer to somebody's input question. So the way of thinking about LLMs and how they're modeled is they're humongous statistical models that do a very, very good job of guessing the next word in a sentence off a huge base of information. So the average human at the age of 10 is trained on about 100 million words. ChatGPT is trained on 500 billion words. So there's a huge difference in terms of the knowledge set of a human versus the knowledge set of an LLM. And as a result, they're kind of dumb models, right? They're not very intelligent in a reasoning perspective, but they do a really, really good job at finishing the sentence. And so this is why to us as humans, we perceive intelligence, because we give them a prompt and they come up with an elaborate story based off all the base material. But in reality, they're just pulling that out of the source data and then doing a very good job of reading it. And they also don't have the same sort of memory which we have in terms of like understanding the context of really being able to answer hard questions to do reasoning. And they're constantly getting reset. So when you're asking ChatGPT subsequent questions, they're actually feeding in the previous question, the previous responses, as context, so it can continue the conversation with you, since it's really a huge base model trained off static data. Now, one way for us to fix this problem with LLMs is we use the advantage. We take what LLMs are really, really good at, so interfacing with humans, finishing the sentence, kind of like doing that interface with us, and then combine that with knowledge graphs, which are a great way of encoding information, encoding enterprise information, encoding fraud information. I'll give some example of knowledge graphs, where there's facts, there's explicit information, and it's something that you can explain. This sort of concept of doing knowledge graphs plus LLMs, or GraphRAG, has been documented in a bunch of articles. So this is a great one on the gradient flow on Substack. Has been documented in research papers. I think the seminal research paper on GraphRAG was done by the Microsoft research team earlier this year. And they showed really strong results of GraphRAG versus doing standard RAG architectures. And in general, the research has shown you get about a 54% increase in accuracy of the results when you do GraphRAG off of a knowledge graph. And even Gartner, to the extent you believe analyst firms, says that 50% of generative AI initiatives will have improved reliability and transparency by combining foundational models with knowledge graphs. Okay, so there's a lot of folks talking about it, a lot of folks doing it, but what is a knowledge graph? And I think an easy way of describing or showing a use case for knowledge graphs is the Panama Papers, which is kind of a classic fraud use case for knowledge graphs. They took 11.5 million documents, or 2.6 terabytes of information about people and their financial records and banks in Panama, so basically offshore banks, and tried to figure out if there was any fraud, if there was any behavior going on where folks were taking advantage of the system. And so, for example, if you found a person who had an account in a bank in the US, and they happened to live in an address with somebody else who also has a company with a bank in the Bahamas, then potentially there's a little bit of money laundering going on, right? So if you see a big transaction where they're removing money from the US bank, the same amount gets put into this Bahamas bank, and that happens to be linked across by these two actors who are in the same household, then somebody's kind of playing a little game here with the system. And knowledge graphs are really, really good at this, because these multi-level, like very deep queries are really, really challenging to do in a typical relational database. But then when you import them into a knowledge graph, out of this huge complex graph where you have all of these different relationships and information, you can start to pull out these little relationships where people are observing behavior or doing things which are not clear just by looking at the larger picture. And we can take the same concepts of knowledge graphs and apply this to LLMs, where if you took an apple and you're trying to describe what the symbolic relationship of an apple was, and you encoded that in a word vector, you would get something like this, where you have a symbolic apple, and then you have all of these nodes which have statistical probabilities of being true. Now, this is great for machines and for calculating things quickly, but we can more easily understand the representation here on the left. So if you have a graph where you can say, okay, now an apple has a structure, has a body and stem, it comes from a tree, it's a kind of fruit. You can start talking about the size and the color and the shape of an apple. Now we can start to reason about, well, is the answer about the fruit actually true? Like is what the LLM telling us true or not based upon this graph? And so by having both a graph and an embedding representation of the same information, it gives us explainability. It gives us the ability to reason about the results and what's coming back from the LLM. So some of the challenges with Gen AI, like a parrot, Gen AI and parrots both learn random sentences from random people, talk like a person but don't really understand what it's saying, occasionally speak absolute nonsense, but one of these is not a cute little bird. And I think this is kind of the challenge with OpenAI and using that as your only way of getting information out of your enterprise data, is it doesn't understand your enterprise knowledge. It can't verify and explain the answers coming back. You suffer from hallucinations. In practice, what this means is if you build a customer service system, rather than getting 90 or 95% correct answers back, you get maybe 70 or 80%. And it may not seem like a big problem to be right 2/3 of the time, but being wrong 2/3, 1/3 of the time and giving somebody the wrong advice, giving someone the wrong outcome actually is really bad from a customer service standpoint. For some reason, we're in slide view. Did I click a button by accident? They'll probably fix that in a sec. So there's a bunch of different approaches we can do this to kind of enhance the model. So you can use an LLM straight. The challenge with that is you lack the enterprise information. You're not able to enrich the model. Now, RAG and vector databases, they actually help with this quite a bit. So if you're taking an approach where you're doing RAG, then you can now import your information into a vector database, create the embeddings, and you're bringing all that enterprise knowledge forward. GraphRAG, which is what I've been talking about using knowledge graphs, that gives you the additional capability of having higher accuracy, better explainability, and then it's suitable for a whole bunch of enterprise use cases where you have a very low fault tolerance for getting back hallucinations or incorrect errors. Here's an architecture diagram for what a typical GraphRAG pattern would look like. And basically what you're doing is you're taking the question that's coming from the user, you pass it to your vector database or your graph database and get back a result, which is both a vector embedding result and also a knowledge graph result. The advantage of the knowledge graph result now is you're not only calculating things statistically on closeness, you can use different algorithms based on the closeness of the nodes, based on approximations of how different things are in the tree. To the LLM as context, you pass back both information on the embeddings and also part of the knowledge graph, so it can use that in the answer. And now when you get an answer back from the LLM, you also have the ability to understand what part of the enterprise database, enterprise data source was used in the explanation that comes back. So it helps with getting back reliable answers, which are easy to explain. There's a bunch of different patterns you can use for this. So a common pattern is text to cipher, where you actually take the text coming in, you convert it to a cipher query. Cipher is the query language for graph databases, or GQL is now the ISO standard for the same. Another way of doing it is you can pass in the query to the vector database, get back a set of embeddings, match those embeddings to the graph counterparts, and then pull back a portion of the graph which relates to the embeddings which are returned. The graph databases also can be used for reprioritization. So when you get back a whole set of results from your vector database, you can use the graph database as a way of resorting and reprioritizing to get a more optimized set of results so that you're making the best use of the context windows. And then you can also combine this with an agentic approach. So if you're doing agentic RAG, Now you can start to look at how you incorporate graphs and graph databases into your agent model for enhancing the results as you do multiple passes and try to tune in on the best result possible. And also, this is great in cases where you want to do governance, because now, since you have a graph and you have relationships between things, you can start to say, well, who has access to this data? Does the doctor get access to the patient's phone number or that personal information? Probably not. Does the agent get access to the diagnosis or the sensitive medical information? And again, that would not be shown to the agent, only to the doctor who's working on it. So you can do role-based permissions and access to who has results coming back from your LLM. And also now you can have explainability, because you can pull back the portion of the knowledge graph which results in the actual part of the answer that the LLM responds. So hopefully I've shown you all how you could get the best benefits of Gen AI and LLMs. Combine that with knowledge graphs and what property graphs and knowledge graphs are really powerful and really good at. And hopefully through this combination of technologies, we go from a future like this. Anybody fans of the Terminator series? Okay, so I think the whole Skynet thing was a big misunderstanding. It was probably an LLM hallucinating, and then they took it the wrong way and they started killing off all the humans, not intended. But if they have a knowledge graph involved, maybe the future would have looked more like this, where robots and humans are in harmony, and robots are saving lives and helping us all to become better at development to solve real-world use cases. Now, I have a couple resources to leave you all with. One is we have a great course on deeplearning.ai that shows how you can build knowledge graphs to solve Gen AI use cases. This is one of the top-ranked courses on deeplearning.ai, so highly recommended. We also have a bunch of free training at Graph Academy, which is the free courses that Neo4j gives to the community. We have a couple courses, so if you're a Python developer, we have a chatbot, basically LLMs plus knowledge graphs for Python. We do the same sort of chatbot for JavaScript. And we have a bunch of other coursework which is in development, so hopefully you'll find some of these resources helpful so you can learn more. And anybody here potential aviator? Okay. Well, maybe you'd be interested in a drone. So if you sign up for our monthly contest, you're eligible to get a drone. We will happily ship it to Croatia. So if you live locally, we'll ship it right to your doorstep. And also, we keep you out of the general marketing funnel, but you'll get some educational resources like the ones I showed you about, like training, courses, and certifications, which will help you to learn about knowledge graphs, Gen AI, and a whole bunch of different graph use cases. So thanks, everybody, for joining the talk, and enjoy the rest of the InfoBip Shipped conference.